So we're here talking about soldering and welding today, and if you didn't already watch the video on soldering, you'll want to do that first because some of the principles in there are going to apply in a little bit more complicated version here. So in this video we're going to talk about welding. And if you remember, the difference between the two is that soldering is a process where we melt a material to hold other materials together, but those original materials are not changed by the process. So if I were to solder together a copper plumbing joint like this, the copper is not changed. What melts is the solder material, which in this case is a mixture of tin and antimony. It melts at a much lower temperature, and it sort of glues that joint together when it melts in there, and then it solidifies again. So this process is fairly easy to use. We can use simple equipment like this propane torch right here, this blowtorch. But it also has some disadvantages. That solder is not, and the biggest one is strength. That solder is not nearly as strong as the original material of the joint. It's a weaker material, it has a lower melting point. And so for a lot of things like plumbing, that's going to be fine. It's a very durable, long-lasting joint. But if we're creating other performance materials like, say, a building frame or a car frame or some precision machinery, we might need something that has more durability and higher strength. So we're going to put our soldering materials off to the side here, and we're going to start talking about the process of welding. Now what happens in welding is that we get our materials hot enough for them to actually melt themselves. So this is steel, and we're going to need to get this steel up to beyond glowing red hot. You know, red, orange, and then we get to the point where the steel itself starts melting in the upper thousands of degrees, or about 1800 degrees. So to do that, we're going to need a little bit more heat than our propane blowtorch can provide. Now, you can actually weld with a lot of different sources of heat. And I'm going to show you about two of those, one of which is not going to be on your safety test. We're going to talk first about gas welding briefly, and then we'll look at getting our source of heat from electricity. You can use other things. People can do welding with just pure friction, where you spin two materials fast enough, they get hot enough on their own, they just melt together with no other source of energy other than the spinning friction. You can even weld melters together with pressure. If that pressure gets so high, it causes the materials to liquefy. But the two most common types are gas welding, using this equipment right here, and then electric arc welding. And of the two, the electricity is much, much more common. But we're going to start off by looking at this equipment just briefly. So what I have over here is a set of two tanks. One of them holds a fuel gas, and holds a gas called acetylene. Acetylene has a lot of energy in it. But to get the acetylene to combust as completely as possible, we're going to mix it with pure oxygen, and that's in the larger of the two tanks. And they both come under pressure, and so they have some valves on the top here that we can control their pressure. And we're going to bring those down through two hoses right here. We're going to keep them separate until we reach our torch body at this point. And then the handle of the torch is actually hollow. And so inside that handle, I can take the tip off. You can see that. That is just a hollow space right in there. And that's where they mix together. And then we'll put a torch tip or a nozzle on the end of this, and that's where they're going to be directed and come out. And because we're using a fuel gas called acetylene with lots of heat value, and because we're mixing it with pure oxygen, this flame comes out really, really hot, in the neighborhood of about 6,000 degrees Fahrenheit. And so it's more than enough to melt our materials together. Now, like I was saying, your safety test is not going to cover gas welding, and so I'm not covering all of the ins and outs of what it would take to operate this equipment properly and safely. This is not a safety briefing on gas welding. But I want to briefly show you this process so that you can see how we can just use heat on its own to create a welded joint, so that when we go to electric arc welding, a little bit of the mystery is cleared up. So I'm going to set this up and then refocus the camera so you can see what I'm doing. So I've set up my two pieces of steel with the help of a magnet to hold them together. This is a common trick that we use when we're welding. If we have two pieces that we want to hold in place, the magnet is going to grab them and hold them lined up the right way. And I've got them on a fire brick here because I might end up dripping just a little bit of material. Now before we start lighting up the torch, I'm going to need to mention some safety equipment here. And a lot of this carries over when we talk about arc welding as well. This gets very hot, and occasionally if we get a bubble, like an air pocket or a gas pocket, we might get a pop and some molten metal flying out just a little bit. So because of that, I'm going to want to provide a little bit of flame-proof clothing, and I'm going to want to cover up my hands and my arms. So I'm going to put a welding jacket on. This is made partly out of fabric. You can get them out of fabric or out of leather. This one happens to have a flame-proof fabric body and then leather sleeves because your arms get a little closer to the material than other things. And then I'm also going to put on a pair of thick leather gloves. Now these are not gloves that will allow me to reach in and grab molten steel or anything like that. These are just going to provide some protection against heat and some spatter and stuff like that. You can think of these as like really they're about the same thickness as oven mitts, just a little tougher with the leather on them. And the third thing I'm going to wear to do gas welding is a pair of dark goggles like this. And that's because as this goes beyond red hot to orange hot to glowing and molten, it is going to be so bright that with my eyes, I can't really see what's going on. I can't see how the steel is melting together and control it. So these goggles right here are going to basically make that dimmer so that I can see the details of what's going on. Now these are particular to gas welding, these type of goggles right here, and we'll find out that you can't use these for arc welding. So I'll show you I'll hold these up to the camera and you can see the shade. Hopefully you'll get an idea of the shade of these. As you look through these, you're not getting a great view there. You can see it's like a pair of dark, there we go, that's probably about the best I can give you. Like a pair of dark sunglasses. Okay, so let's bring that camera around and let's set up to do some gas welding. Okay, so there you can see the piece of material that I'm going to weld in the torch. And the first thing I'm going to do is I'm going to light the torch, and then I'm going to start heating up this material. Now, it is possible to melt that material in such a way that I don't need any extra steel. But because this joint right here is the way that it is, in fact most joints, we're going to need to add a little bit of extra filler material into that. So I'm going to put, as I go and as I heat this up, I'm going to dab in a little bit of extra material into that as well. So you'll see me hold that with my left hand. Okay. Again, this video is not intended to be a full safety briefing on how to use the torch correctly. So I'm not going to go into the details of exactly how I'm lighting this. But we're going to start off with some acetylene here. Running into a problem again, so hold on just a second. Okay, running into some problems with my spark igniter again. I went and got the heavy duty version right here. So we're now go ahead and bring in the acetylene, like that. And then we're going to mix in some oxygen. And if I add in too much at a time like that, it actually goes out. So there is a little bit of an art. It's called getting a neutral flame. It's a little bit of an art to getting exactly the right mixture of oxygen and acetylene. Now that little bitty blue flame right there, that is actually the hot flame that we were going for. That's our welding flame. So I'm going to bring that down, and I'm going to melt, starting at the corner. There's one of the pops that I told you about. I got a little bit too close with my welding gas. I'm reaching around the camera here, so that is not giving me the most dexterity. when we let that cool down, what we'll find out is that we have two pieces of steel that are joined completely together. I'm going to peel them off the magnet at this point. So there we go. I got to tell you, that's not the world's prettiest joint right there, but that is one solid piece of steel with a little bit of filler metal attached into it as well. Now I've taken that piece of steel and I've cooled it off in some water, and then I took a wire brush and I cleaned up the weld just a bit. And so what you should be able to do here is see that joint a little bit more closely. And again, that is all steel. There's no other material in there. So the entire joint has the strength of steel. And you can also see in this that the heat affected zone has reached all the way down to this oxidation down here. You might wonder, you might be asking the good question, well, doesn't the oxidation in this area here affect the strength of the joint? And the answer is, if done properly, no, because the torch, when we adjust the torch so that it burns all the oxygen cleanly, the flame is actually going to push any excess oxygen out of this area. We can see there's some down here, but this area here is pretty much clean of any oxygen, and so we get a nice solid joint there with that without having to use any flux. Now I should mention one of the other safety precautions when it comes to welding is that we never assume anything like this is cool to the touch. Just because it does not glowing red hot doesn't mean that it's still not hot enough to burn us. So we want to get in the habit, if we have a piece like this, once we've started doing any welding, to feel for heat with the back of our hand first. Our back of our hand's more sensitive than the front. So I'm going to see if I feel any heat radiating off that. And if not, then what I'm going to do is I'm going to come in, I'm going to touch it gently, very quickly, because if it is hot, then I'm going to know that without hurting myself, and then holding it a little bit longer, and then finally pick it up like that. So when you're doing any sort of soldering or welding, resist the temptation to grab anything, whether it's a piece of material or a tool like this, or your torch. Get in the habit of feeling for heat with the back of your hand, carefully touching it, and then picking it up to avoid burns. So we're going to move on from gas welding, and we're going to talk about the more common form, arc welding. I wanted to show you that this joint here tends to put a lot of heat into the material. That's a trait of gas welding. So we've got a really big zone that's been affected by the heat, which sometimes matters and sometimes doesn't. And we get a weld joint that tends to flow out a little bit more than we will with arc welding. Also, this equipment here, this torch, and then the supplies, the gas is heavy and expensive to operate, and it doesn't operate as quickly as arc welding. So this is a technique that you won't necessarily see used all that often.